In this video, we're going to discuss the reactions of carboxylic acids and esters, as they are intimately linked. So a carboxylic acid, we generally can form by taking an alcohol and adding oxidant. It initially makes an aldehyde, but this will continue to react with any oxidant around to produce a carboxylic acid. And so alcohols plus 2 equivalents of oxidant can turn it into a carboxylic acid, or an aldehyde plus 1 equivalent of oxidant will turn it into a carboxylic acid. This is generally how we form carboxylic acids, but what can we do with them? Well, there are a couple different reactions carboxylic acids undertake. And one is for our carboxylic acid to become an ester. To do this is the ester formation method. I have a carboxylic acid and I have an alcohol. What will happen is that the oxygen on the alcohol has lone pairs. They're really good at attacking the double bonded carbon. And the result is that it kicks out that OH. Now, the whole mechanism is actually far more elaborate, but the net result is this hydrogen hops over onto that OH. What you end up with is an ester, where the oxygen that is bonded to the 2 carbons actually came from the alcohol. And additionally, you end up with water. This is how you form an ester. It actually takes a carboxylic acid plus an alcohol. And so any carboxylic acid, let's say I've got propanoic acid and I've got methanol. If I combine them, I will end up with methyl propanoate, and I'll end up with water. There are 2 parts. There is the alcohol side, the oxygen that is single bonded to carbons, and there is a carboxylic acid side that has the oxygen double bonded to carbons. This is where we actually create the ester. If you had a bunch of liquid alcohol, so pure ethanol or pure methanol or something like that, and you throw some carboxylic acid in and you start to bubble it, just boil it, you start to boil it, what will happen is they will combine, make an ester, and some water. In general, a few drops of concentrated sulfuric acid and some light heating tends to be enough to promote this reaction. Well, you can use carboxylic acids to make esters. They're also what happens when your ester reacts. So ester reactions. If I have an ester, I can add water and I can break that ester. You can break those parts apart. You'll end up with a carboxylic acid and an alcohol. If we do a little color coding, the water actually attacks the carbon that's double bonded and it shoves out the whole alcohol side. And so, since oxygen only wants 2 bonds, it ditches the oxygen from the water, ditches one of its hydrogens, passing it off to the alcohol. And so this is a way that we can form carboxylic acids and alcohols from an ester. Mostly this is breaking an ester. So deesterification is to separate these into carboxylic acids and alcohols. There's an additional similar reaction, which is called saponification. You start the same. I have an ester. Except this time, instead of adding water, you add NaOH, or perhaps KOH, either one. Sodium hydroxide or potassium hydroxide, well, that still has an OH, but it's OH minus. That goes and attacks that double bond carbon. It breaks the alcohol free. You end up with R, except what happens is I only have one hydrogen. I can't put one on each of my oxygens like I could when I added water. One of these is going to get a hydrogen, and one of these is going to get a potassium. And it works out that the potassium goes on the carboxylic acid, and the hydrogen goes on the water. I think that's technically that oxygen would come from the hydroxide. But carboxylic acid is an acid. Acids want to give away H+. And so a carboxylic acid, by its very nature, doesn't want the H+ nearly as much as the alcohol does. And so this is why that positive cation from the potassium ends up on what amounts to a carboxylate, a negative anion. And so we have a potassium carboxylate, and we have an alcohol. This is common in soap making. Saponification is the reaction to produce soaps. We do this to fats. Fats are triesters. So when we talk about lipids, we'll see it more. But a fat has oxygens coming off a carbon chain that form esters with really long hydrocarbons. Maybe some double bonds in there. But this is the general idea of a fat. So if you take fat and you add lye, what you're really doing is you are breaking your ester apart and producing these carboxylates. And so you end up with K plus O and a really long chain. This is the general shape for soap. And so we'll talk about it more in lipids, but saponification is a slightly different version of breaking an ester where you use a hydroxide instead of water, and it produces a deprotonated carboxylic acid instead of a normal carboxylic acid.